class. Today we're going to talk a little bit about one of our fundamental and literally underlying classes of resources as they matter for forest recreation management, and that is bedrock and topography. So the basic idea here is that the shape of the earth kind of determines a lot. It determines the weather patterns around it. For example, the lenticular clouds or lenticular halo clouds, or the localized weather system for very tall mountains like Fuji in Japan, or Denali up in Alaska, the tallest peak in North America, around 21,000 feet. These mountains are so big they force air like the jet stream completely over them and just utterly rewrite the typical weather patterns for that particular spot. Now, imagine that effect of a single mountain peak like Denali or Mount Fuji in Japan, and multiply that along an entire single mountain range, and then multiply that effect across multiple sequential mountain ranges that winds and prevailing weather patterns and climate, as far as it determines local weather patterns. Imagine it having to hit a speed bump with each one of those mountain ranges, and as the air gets forced up, it undergoes what's called adiabatic expansion. It cools off, it dries out, it loses its ability to hold water vapor, and so on the windward side of a mountain you typically see it a lot wetter. On the leeward or sheltered side, the backside, we get an effect that's noticeable in the landscape called a rain shadow. So in the dry desert Southwest, one reason that it's so dry and deserty in the Southwest, even though the Pacific Ocean is blowing lots of, the Sea of Cortez, or the that sort of counterpart to the Gulf of Mexico, they're blowing lots of warm, wet air, saturated air from the Pacific Ocean and that sea all across this really pretty dry area, because they're hitting the basin and range formations in the Colorado Plateau of the dry Southwest. So New Mexico, Arizona, they have a whole bunch of kind of parallel and sequential mountain ranges as you move west to east. And so the warm, water, moisture-laden air from the Pacific hits the first one of those, dumps a bunch of its moisture, and hits the next one, dumps most of what's left, hits the next one, dumps most of what's left. And what you're left with is basically very little water in the air, and you get deserts even close to huge water sources like the Pacific Ocean. So we want to understand that in terms of its kind of driving effect, topography's driving effect on weather patterns, because that's going to make pretty strong determinations about what kind of forest, what kind of vegetation can grow in a particular area based on those weather patterns. We might have something as wet as the Pacific Northwest's rainforests, temperate rainforests. Those would be jungles if they were further south, but we have feet of water dumped in the Pacific Northwest every year, and everything grows beautifully there, right? Just the gardens, the lawns, the forests for timber and resource extraction, and then of course lots of spaces given aside for forest resource recreation and hunting and fishing and wildlife management, all this stuff. A lot of it's kind of dependent on how much rain hits it, and how much rain hits it is very much dependent on the shape of the earth leading up to that spot in the upwind direction. Another place that we see this playing out is here in the Midwest. So here, where it's relatively flat, we have the grain basket of the Western world in these Midwestern states. And what that means is that this is a place where we can rely on wind energy tremendously. Driving across Kansas for a recreation summer camp each year, or most years, we go through these huge wind farms, and we can power lots of homes and so forth with that, and increasingly lots of vehicles, including recreational vehicles, as we switch over to lithium-powered and eventually sodium-powered vehicles. So that's all pretty cool, and it all entirely has to do with the shape of the earth. So topography, the conformation, the convexity, or the concavity of the earth kind of determines, in a large way, the forest that we're working with for recreation management. It also has a lot to do with the kinds of places that people seek out. Like we are, the evolutionary biologists would suggest, we are evolutionarily adapted to want to be able to stand up, look over that svelte or savanna grassland, amber waves of grain, so to speak, if you want to think of it that way, and be able to see the tail of the lion swishing in the grass. So we have a fascination with high points and summits, and in Colorado there's this whole sort of subculture around peak bagging, or catching all the 14ers, walking up or driving up all of the 14,000 plus foot peaks in that particular section of the Rockies. It's lots of fun. And you get some amazing views and selfies with your selfie sticks and your duck lips, and it's a thing. What it also does is it helps determine, what topography also does is helps determine where key resources that people want to visit in terms of recreation, where that's kind of the point of their trip. Wildlife photography is huge. Bird watching, huge. One of the most popular activities on Earth, believe it or not. And what that means for topography's presence and effects is kind of everything. Yellowstone had to be connected to Grand Teton National Park out west in Wyoming because the bison moved from the high plateau of Yellowstone down to the low plateaus and plains around the Grand Teton Range. And if we fence all that in with a bunch of barbed wire fences, as we once had, then those bison populations collapse almost immediately because they get pushed up against the fences, and then those crazy prairie storms, winter storms, just freeze them all in place in herds by the thousands. So topography is a pretty big deal. Elevation and topography work in synergy. So a couple of our examples for today's class are all about what's the combination of topography and elevation, or you can swap in latitude. So the farther you get from the equator, it's very much equivalent to, almost identical to, the effect of going up in elevation. So we'll see one or a couple of examples of how that kind of plays out. And this is kind of intuitive stuff, but think about all the other types of resources that we're going to be talking about this semester and how topography kind of drives them. So that's why we're kind of starting with this. That is, if we have some combination of topography and elevation, or maybe topography plus latitude, like getting up towards Canada, things get a little bit colder, or some combination of the three, like topography plus elevation plus latitude. Montana, for example, has high elevation, high latitude for the United States, and has high elevation, high topography. The surface of the Earth, as viewed from space in Montana, is rugose, or a technical term for very rough, right? The sub-Canadian Rockies are all throughout western Montana. It's a beautiful place. So what that means is short growing seasons. It means relatively thin, hard-hit soils. It means crumb-holes trees. So for those of you not in forestry, a crumb-hole's sort of a German word for a not-so-great tree, where it's right below tree line, and a tree might only be a foot or two tall, but that individual tree at a foot or two tall down in the valley might be 100 or more feet high at the same age, say 100 years. Or 75 years, or whatever it is for the species. So we have a lot of human effects and interactions and desire to go to these places where topography is rough, where elevation is high, because we have these sick videos and pictures and panoramics of gorgeous mountain ranges you can see real far because you're up over the hazy kind of low elevation particulate stuff that kind of blocks off the far horizon when you're up on a mountain. This pushes a lot. So let's wrestle with that. We'll see some sort of bare effects on just forest composition, and then we'll build up from that to what are some of the effects on human recreation. How do human recreationists affect these places that have strong presence of topographic factors, strong presence of elevation, strong presence of latitude factors. Okay, so take a look at this content, and if you have any questions, bring them up with the class, and we'll wrestle with that together.